Hello dear students, welcome to chemistry class. In this class we will discuss about the ionic bond and examples for the ionic bond and the factors which are affecting the formation of ionic bond. Okay. Then what actually the meaning of ionic bond? This ionic bond is also called as a electrovalent bond. This ionic bond is also called as a electrovalent bond, and it can be defined as the bond formed by the complete transfer of one or more electrons. The bond formed by the complete transfer of one or more electrons from valence shell of one atom to the valence shell of another atom. If a bond is forming by the complete transfer of one or more electrons from the valence shell of one atom to the valence shell of another atom, then that bond is called what? Ionic bond or electrovalent bond. Take for example, bond formation between sodium and chlorine. Bond formation between sodium and chlorine. See here, sodium having an atomic number of 11, and here I am writing its electronic configuration 1s2, 2s2, 2p6, 3s1, and here this 3s1 becomes the valence shell. Valence shell means what? Last shell or the last orbit, and here I am writing for chlorine. Its atomic number is 17, and here its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p5, and here its valence shell is 3s3p. Then now, according to the octet rule, these two atoms are unstable and they want to get stability by completing their octet, and here the sodium is having one electron. Then after losing this electron, it will have 8 number of electrons in its next cell. Then after losing this one, it becomes 2s2, 2p6. Then this second orbit becomes the valence orbit or valence shell. Then here, after gaining one electron, this will becomes 8 number of electrons in its valence shell. See here, I will write the electron dot structure for sodium and chlorine. Here it is having only one electron, and here it is having 2, 3, 7 electrons. Then now this sodium will transfer one electron to the chlorine. Then after the transfer of one electron, this sodium neutral atom becomes Na+. Then after gaining one electron from the sodium, this chlorine will becomes a chloride, Cl-. Then now I will write again the electronic configuration for this Na+ and Cl-, 1s2, 2s2, 2p6. See here, now this 2s, 2p will becomes the valence shell, and here according to the octet it is having 8 number of electrons, therefore it is a stable one. Then now after gaining one electron, this chloride becomes 1s2, 2s2, 2p6, 3s2, 3p6. Then here this 3s, 3p is having now 8 number of electrons. Then both the atoms get their octet and they are now stable. Then now this is positively charged atom and it is a negatively charged, positively charged ion and negatively charged ion. Then we know that the opposite charged species will get attract towards each other. Then these two oppositely charged ions will now combine to form a bond that is called ionic bond. Here one electron from the sodium atom, that too from the valence shell of sodium atom, is completely transferring to the valence shell of chlorine. Then hence after the formation of ions, there exists an attractive force between the opposite charged species which results in the formation of a bond, and this bond is called what? Ionic bond. The bond formed by the complete transfer of one or more electrons from valence shell of one atom to the valence shell of another atom, and hence it forms an ionic bond. Take another example. Take another example. Bond formation between calcium and oxygen. Bond formation between calcium and oxygen. See here, what is the atomic number of calcium? 12. I will write the electronic configuration: 1s2, 2s2, 2p6, 3s2. And what is the electronic atomic number of oxygen? 8. Electronic configuration is 1s2, 2s2, 2p4. Correct? 4 plus 4, 8. And here this oxygen needs 2 more electrons to complete its octet, and here this calcium wants to lose these 2 electrons to complete its octet. After losing these 2 electrons, it will get the nearest noble gas electronic configuration, that is of neon 10. Therefore, this calcium will lose 2 electrons to the oxygen, means complete transfer of 2 electrons from the valence shell of calcium to the valence shell of oxygen takes place, which results in the formation of Ca2 plus ion and O2 minus ion. Then after the loss of 2 ions and after the gain of 2 after the loss of 2 electron and after the loss of gain of 2 electrons, these will have the electronic configuration of this type. Complete octet is there here, then here 1s2, 2s2, 2p6, complete octet is there here. Then now electrostatic force of attraction will exist in between these 2 oppositely charged ions, which results in the formation of calcium oxide. This is one more example for the ionic bond. Dear students, ionic bond means the bond formed by the complete transfer of 1 or more electrons from the valence shell of one atom to the valence shell of another atom. From these 2 examples, we can clearly understand the meaning of ionic bond, and this ionic bond is also called as what? Electrovalent bond. Okay. Then now we have to discuss about the factors favoring ionic bond. Factors favoring ionic bond. And before starting this one, let me explain something. If a system is there, then if the energy of this system is less, then we can easily say that this system is stable. If this system is having less amount of energy, then we can easily say this system is stable. And if the energy is high with this system, then we can say this system is unstable. Then if the condition is there to add energy to the system, we should add very less amount of energy to the system. Hence, the system will remain only with a less amount of energy, and hence it becomes stable. And if a condition is there to remove energy from the system, we should remove more amount of energy, or as much possible energy from the system we should remove. Then the system will remain only with a less amount of energy, and hence it will becomes more stable. And now the first factor is low ionization energy. Low ionization energy. Then what do you mean by ionization energy? What do you mean by ionization energy? Ionization energy is nothing but the amount of energy required to remove the electron from the outermost valence shell or valence orbit of an atom. In removing this valence electron from the atom, we have to supply some amount of energy. That energy is nothing but ionization energy. Why? Because initially it is a neutral atom, then after the loss of electron, it is forming into a positive ion, ionic form. Therefore, it is called ionization energy. And we know that this ionization energy is inversely proportional to the size of an atom. Ionization energy is inversely proportional to the size of an atom, and in the periodic table, the ionization energy goes on increases from left to right of the periodic table. Why? Because in periodic table from left to right, the size goes on decreases. As the size decreases, then automatically ionization energy should increase. Then we know that in the periodic table, the ionization energy is decreasing from top to bottom. Why? Because in the periodic table from top to bottom, the size goes on increases. Then if the size goes on increases, then automatically the ionization energy decreases. Why it is happening? If the size is large, then the attraction between the nucleus and the outgoing electron is less. Then to remove that electron, we require only less amount of energy. And if the size is small, then the attraction is more. Then to remove that electron, we should supply high amount of energy. Therefore, here one of the combining atom should possess low amount of ionization energy. Then from periodic table, where we will get these type of atoms? The atoms of group 1 and group 2, that is alkali and alkaline earth metals, will form these type of ionic compounds. Then the second one is high electron affinity. High electron affinity. Then again, what do you mean by electron affinity? Here in ionization energy we have removed one electron. Then now in next step we are adding that electron to the another atom. In doing so, in the addition of this electron, this atom is releasing some amount of energy. Then we can define this electron affinity is the minimum amount of energy or the amount of energy released when an electron is added to the neutral gaseous atom. This energy is called electron affinity. And if the higher energy is releasing, then the system will be more stable. Higher energy is releasing, the system is more stable. And here also we can write electron affinity is inversely proportional to size. If the size of the atom is small, then it is having high electron affinity, means high amount of energy is releasing while adding the electron. If the size is large, then less amount of energy is releasing while adding the electron. Therefore, in the periodic table we can write electron affinity increases from left to right of the periodic table and it decreases from top to bottom of the periodic table. Okay. And here we can easily write non-metals. Usually the elements of group 16 and elements of group 17 will form these type of ionic compounds. Then the third one is high electronegative difference or electronegativity difference, high electronegativity difference. Then what do you mean by electronegativity of an atom? Electronegativity of an atom is nothing but its ability to attract an electron towards its center. If the electronegativity is high, then that atom is attracting more strongly the electron towards its center. Then if the electronegativity is less, then that atom is loosely attracting or less attraction is there towards the electron towards its center. Okay. Then here they are telling high electronegativity difference should be there between the combining atoms. If an atom A and B is combining to form ionic bond, then there should be high electronegative difference between these two. Then if the atom A is losing electron, then if it is gaining electron, then there should be an high electronegativity difference should be there in between these two. Then only the one atom is losing electron, then the another one is gaining electron. Take for example, sodium chloride and sodium iodide. Here we can easily say that sodium chloride is more ionic as compared to sodium iodide. Why? Because the electronegativity of sodium is 0.9, then that of chlorine is 3.0, then that of iodine is 2.66. Then here the electronegativity difference is more as compared to these two, therefore it is more ionic as compared to this one. What happens if the electronegativity difference is high? One atom will lose electron very easily and the another will get or gain electron very easily, and hence it will result in the formation of an ionic compound. Then the fourth one factor that is affecting the formation of ionic bond is large size of cation and a small size of anion. The fourth factor which is affecting or which is favoring the formation of ionic bond is there should be a large size of cation, means the atom which is forming a cation, and the anion should be small, means the atom which is forming anion should be small in size. Why? If the atom is large in size, we can easily remove an outermost electron and hence we can easily get a cation, and if the atom is small in size, that atom will easily attract an electron and hence it can easily get converted into anion. Therefore, the combining atom should be have high difference in their sizes. Okay. Then for this we can write cesium, which is having high size, rubidium, potassium, sodium, lithium. Okay. And coming to the negatively charged atoms, fluorine, which is having small size, is forming more ionic compounds as compared to chlorides, as compared to bromides, as compared to iodides. It is all depending on their size only. Okay. Then the last one factor which is affecting the formation of ionic bond is high lattice energy. High lattice energy. This can be represented as U or L. High lattice energy. Then what do you mean by lattice energy? It is the amount of energy released when a cation and anion are brought from infinite or infinite distance to their respective site in forming an ionic compound. Or we can say lattice energy is the amount of energy released when 1 mole of an crystalline solid is formed by the combination of oppositely charged ions. And as we have discussed here, this is also an energy releasing process, and here we should release or we should remove as much energy as possible to get a less stable or less energy with the system. Therefore, the system will get a stability. Therefore, the combining atom should combine by releasing high amount of energy. Okay. And about this lattice energy we will discuss in next session. More in detail we will discuss in next session. This is all about the factors which are favoring the formation of a ionic bond. Then now we will discuss about the physical properties of ionic compounds. Physical properties of ionic compounds. The first one property is these ionic compounds or ionic substances are crystalline solids in nature. These are available to us in their solid form, that too crystalline solid, and they are hard in nature and they are brittle. They are brittle and they have high melting point and boiling point. These ionic compounds have high melting and boiling points. Why? We know that the ionic bond is very strong bond because it formed between the oppositely charged ions. Therefore, to break that bond we require high amount of energy. Then these behaves as poor conductors of electricity in solid form. In solid form, these ionic compounds are poor conductors of electricity, but in molten state or when dissolved in water, these will behave as a good conductor of electricity. Why? Because here the ions are responsible for the conduction of electricity. In solid form, both the oppositely charged ions are held with a bond, and in molten or in dissolved form, means in aqueous form or aqueous state, those ions are free to move here and there, and they can easily carry the electric current. Therefore, they are good conductors of electric current in molten or when dissolved in water. Then the last one physical property is their solubility. They are easily soluble in polar solvents. These ionic compounds are easily soluble in polar solvents like HCl, H2O, etc. But they are insoluble in non-polar solvents like ether, benzene, carbon tetrachloride, etc. Why? We know that these ionic compounds are polar in nature because they have positive pole and a negative pole, and we know that like dissolves like. Therefore, to dissolve this polar compound, we require polar solvent only, and hence these ionic compounds are soluble in polar solvents and they are insoluble in non-polar solvents. This is all about the ionic bond and the factors which are affecting ionic bonding and their physical properties. Thank you.